hey y'all, I just got into the craziest argument with my friend Scarlett about the hottest summer trends. She thinks crop tops are all the rage, but I'm pretty sure it's leather. Trends are so hard to keep up with. But you know what? There are 4 trends in chemistry that never change. And I'm going to show y'all some tricks to keep them straight. We're going to look at atomic and ionic radii, ionization energy, and electronegativity. I know, those are some big words, but don't worry, I'm going to talk you through it all. So why do we have to know this stuff? I admit, chemistry stuff is pretty far out there, but chemists like predictability. Information, just like these trends, helps chemists determine if a reaction will work or not. That way, they're not wasting a ton of time and money trying to make something work that just won't. And I think you like predictability too. You like knowing that school will get out at the same time every day. All right, let's do a quick review. You've got your periods and you've got your groups. Periods run left and right across the table. Groups are columns that run up and down. Got it? Cool. All right, now we're ready to set some trends. The first trend we're going to look at is atomic radius. Simple enough, right? Scientists have always wanted to know how big an atom is. So what do you think? Are all atoms the same size? Well, they're actually not. The largest atom, cesium, is just under 6 angstroms in size. And the smallest one, hydrogen, is about 1 angstrom in diameter. By the way, an angstrom is 10 to the minus 10 meters. Crazy, right? The size of an atom decreases from left to right and from bottom to top of the periodic table. As you move left to right across the period, the atomic number increases. See, here's boron, carbon, nitrogen, and oxygen. As the atomic numbers increase, so do the number of protons. There are also more electrons, but with each additional proton, the electrons are held tighter and closer to the nucleus. So, which atom has a larger radius? Carbon or oxygen? You got it, it's carbon. Here's a picture of a whole lot of radii. As you move down a group, the atoms get bigger too. Here's our big boy cesium. There's hydrogen, the smallest atom. And these atoms at the bottom are fat because they have more energy levels than those at the top right. Kind of looks like hydrogen should go on the right, doesn't it? Anyway, we've looked at the size of single, uncharged, neutral atoms. But what about ions? Yeah, those change the size too, OMG. Now remember, cations are positive. Cations are smaller than uncharged atoms because there are fewer electrons, and the positively charged nucleus pulls in the remaining electrons even tighter. Anions, such as the chloride anion, are larger than an uncharged chlorine atom. More electrons means a larger electron cloud and a larger radius. Okay, periodic trend number 2 is ionization energy. This trend looks at how hard it is to remove an electron from an atom. Group 1 and 2 elements easily give away their electrons. Groups 17 and 18, not so much. Halogens, for example, are super close to having 8 valence electrons, so they have a high ionization energy. Ionization energy increases from left to right. It also decreases as you go down a group. Electrons are easier to remove from the large atoms because their VEs are farther from the pole of the nucleus. Those big fat atoms at the bottom could care less if they lose an electron or two. All right, one more trend, I promise. The last trend is electronegativity. This trend looks at how badly an atom wants an electron. The trend is simple. The closer an element is to having 8 VEs, the more electronegative it is. And remember, all atoms are wannabes. Fluorine is the most electronegative and biggest wannabe of all. You could say the closer an atom is to fluorine on the PT, the more electronegative it is. Fluorine is ultra-electronegative because it is small. Its compact size means the electrons are held tightly, very close to the nucleus. No one can steal from flow. The smaller the atom, the closer it holds its electrons, the greater its electronegativity. This trend increases from left to right and from bottom up. All right, real quick, let's summarize the trends. No, not fashion trends. We are still talking chemistry here. Let's forget about hydrogen for a moment. Let's picture what happens to the trends as they move across the PT closer to fluorine. Atomic radius. Fluorine is the smallest. Ionic radius. Cations are the smallest. Ionization energy. Fluorine is the largest. Electronegativity. Fluorine is the highest. So, why didn't I just show you that to begin with? Because that would have been too easy. All right, it's been fun, y'all. See you later.